Okay, Assalamu alaikum, everybody. Good morning. To those of you that are not Muslim, who have decided to tune into this video today. I am helping because I've had a request to help plan a curriculum. This particular parent wants to use the national curriculum as a framework, but they also want to be able to maneuver in and out when they need to and find the gaps for their children. I'm going to base this off my own daughter. Because I know her. So it's quite easy for me to just go ahead and see what's going on with her. If we can look, I'm using the National Curriculum Guidelines for our aims for the year. There are only mainly 3 aims on the national curriculum for the Key Stage 3 element. And the main things that we've got bolded out on this idea is the idea of fluency. So they are required to be fluent. They also need to be able to reason mathematically, and they also need to be able to solve problems. The main thing with that, with fluency builds speed. And we all know exams are timed. If they choose to do GCSEs, even if they choose to do functional skills, everything is timed. And they need to consider the concepts that they're being asked for. So if for indeed it is a word question, for instance, what is it about the word question which is not reaching them in terms of understanding? Is it that they require more practice or seeing the same sort of question over and over again? That's a child who, when it comes to revision or comes to tuition, you may need to speak to their tutor or adjust the way you are teaching so that they are able to just practice and recall the same thing over and over again till it's rapid and accurate. For that, even though she is much older now, when it comes down to the idea of things like resources, I will go ahead and use an app called Extra Maths. Even though I know that the stuff that she is able to do, it means that I can be sure that this can be done without hesitation. That's what we're trying to get rid of, is that hesitancy of second guessing themselves to decide that this is going to be an issue. We don't want it to be an issue. So that's where we got the idea of become fluent in the fundamentals of maths, including through varied and frequent practice with increasingly complex problems over time. So going up in the idea of the questions progressively getting harder until we've got to a point where we are at exam standard, so that the pupil develops conceptual understanding and the ability to recall and apply knowledge and information accurately. No problem. So it means that when we get to a point where they're getting at least 80 or 90% of the questions that you've put in front of them correct, they need to be able to reason mathematically and follow a line of inquiry. This is very important when they are doing their own working, but it's the idea of if they are doing their own working and the answer is indeed incorrect, or the answer is correct, but the method looks slightly off, you get them to vocalize. Maths is the idea of they need to know what they're doing. So it's the vocalization of their understanding that they are able to then say to you, okay, this is how I did it. This is why I did it that way. But then it's even more important when they are doing a question, for instance, and they get the question wrong. That's where I find this actually more valuable. Because when it's the idea that the answer that they've given is incorrect, you can see that it's incorrect. The mark scheme for whatever questions you're using, even if you've made up the questions yourself, are still incorrect. You know that then there is a breakdown somewhere. Somewhere they're not able to quite grasp what's going on. So you are able to fix that particular problem, and you're not then searching for a needle in a haystack and going back over the entirety of their curriculum to say, oh, I need to go back and they don't understand anything. Let's throw the baby out with the bathwater. We don't want that to happen. What we want to happen is to find the exact problem. If the exact problem is they are comfortable with one type of method, that's fine. Because I've taught particular students where they are more comfortable with using quadratic formula rather than factorization because they are comfortable with quadratic formula. No problem. The issue is they need to then be able to recall and use quadratic formula very, very quickly to get me an answer. But then putting it into brackets, I would say to them, go ahead, show me how you would do that and work it backwards. They have the ability to solve problems by applying their mathematical knowledge to a variety of routine and non-routine problems. So you have some problems which are very standard. We see them a lot, they reoccur, but then sometimes you have new phased questions that are plugged in and they look more like they belong on a different type of exam paper. So for instance, something like a velocity question, which ends up coming up, but in maths, it's actually not velocity, it's a differentiation question. Teaching them the idea of differentiation, it needs to become increasingly sophisticated. So start off with differentiation. Yes, by all means, teach it as a basic, but then also show them how to identify it in other questions. A very good website for that I will put in the chat is the idea of Maths for Everyone. Maths for Everyone will show them systematically how things work for them to develop that idea of fluency and finding out how different things work in different questions. I use it with my own students. I use it with my own kids. I'm also a home ed mum, so I sort of understand what I'm looking for when I'm looking at resources. We're going to have a table because my brain just works better that way. And it's also really easy to then provide this sort of information to a local authority in the idea of a written report, what they're actually doing, where they're coming from, where they're going to. And it's the idea, but at the end of Key Stage 3, in terms of Key Stage 3 maths, we should be able to know whether we're going to choose for this particular student to sit the foundation paper, if they'd be more comfortable there, or if they're going to sit the higher paper in terms of their examinations. We need to know if it's going to fit there. So what I would do in my idea is the notion of previous knowledge. Because we are home educators, we've got liberty to work with this really well. Do we have any trips that are going to reinforce what we are knowing? But I'm going to put trips further across in here because I need it to coincide with other things. So if we have previous knowledge, which bits are we going to work with first? So if I need to work with their previous knowledge, I need to go back and I'm going to use the words from the actual national curriculum, which is to consolidate their numerical and mathematical capacity from Key Stage 2 and extend their understanding of the number system and place value. Because we need, for this point, at this point, it needs to start including things such as decimals. And if we're including things such as decimals, fractions, roots, and powers, because sometimes you get on an exam paper that a particular student needs to go back and do certain things. So I've put that into the idea here, but I'm going to move my table slightly down so it's still, I wanted to move my table onto the next page so that it's underneath my aims, but my aims don't want to play ball in this idea. So we'll leave it like that and I'll deal with the formatting afterwards. And now it doesn't want to play ball at all. Let's see what's going on here. We have a problem, Houston. And we're going to deal with that problem right now. Let's put that table back in. So starting from the beginning, all over again, happens to the best of us. And that's why periodical saving of the things that you're doing is always a good idea. And I really should learn that by now. Right, so let's go from the beginning. So I'm going to insert here the header again, and my header for this one is going to be for a year 7 female, and then we'll go back and put our aims in again. Bear with me a second. I managed to retrieve everything that we've done so far so that we don't have to go back and do that all over again. So we go down to here where our table is, and we're just going to move that up slightly. Hopefully it plays ball this time. Right, so we're consolidating their previous knowledge, and it's the idea of, I know what her previous knowledge is, so the idea of having fluency with number lines, and depending on whether you used a curriculum for Key Stage 3, Key Stage 2, you could slot all of the things that they are capable of into there. And then I've got, throughout here, I would then put several skills that I want to develop. So things that I want her to develop and individually what I want her to develop. So we can look at that in a moment. It's the idea of we're looking at, then I am going to set out the curriculum the way that it is set out. This is a very complex piece of text. So I'm going to set it out exactly as I need it to be set out. I will miss a line, and in here I'm going to put all of the things that I need to do with number work. Because number work is something that's very, very important. And when it becomes very important is we can't start algebra until our number concepts are solid. So I've put down our number values that I need her to deal with, and it's to use the idea of place value. We're going to put in integers of any size. So I need to test that she has the ability to do that before we can move on. Then we will move on to what usually comes up in the front of your textbook or whatever you're using is the idea of prime numbers, factors and dividers. So knowing that the language is interchangeable, factors and dividers, knowing the difference between the way terminology will be raised to them is also very, very important. Because you may get a student at some point, and I had a great encounter of this year, where a student tackled a question on their exam paper. So I tutor also, and our student came back from his exam and said to me, okay, we did the exam really good, but there was one particular question that I didn't understand. And I always ask my students, what was the question? And could you tell me what the question actually was? So I can help you figure out where you went wrong. Just for the idea of a debrief and a correction so that they feel perfectly fine. So not to do with number work per se. It was a geometric question. So a question that factors in geometry. And they were able to recall the question because it bugged them quite a bit. And it was a simple thing that he missed out the entire question on the basis that he didn't, his brain, I think at the time, I know that he knows this stuff, but his brain at the time did not go into the idea of saying, perimeter, shape, circumference, circle. He didn't make that connection mentally. And because he didn't make that connection mentally on the day, it meant that he missed out on nearly 6 marks. But I had been honing that in on him for a while. And he said, now that you've said it again, I can hear you in the back of my brain saying circumference is the same as perimeter, but circumference is for circle. Perimeter is for a shape that is not a circle. He said, I can now recall hearing you say that, but at the time, I think nerves got the better of me. And that's something we always need to think about is when we're testing our children, it may not necessarily be that they don't know the content. It may be nerves. So if you are going down the route of testing, you also have to consider that there might be nerves involved. I filled in some of the table as I was talking. So we've got understanding decimals and integers of any size, so whole numbers of any size. And then we've also got to order positive and negative integers, decimals and fractions, and using a model for that. I would also then, when I'm looking at number work and I'm looking at things individually, I would go through these individually. Planning for a year does take time. So I wouldn't say to you, don't do it. I'd say to you, if you are doing it and you know it's overwhelming and you only have a small amount of time to be doing something, no problem. That's not necessarily an issue. We're all planning this around our lives. Take 10 minutes and do part of it and then come back and do the other part. Go and do whatever you need to do. Take 5 minutes, come back and do where you left off. So if we are doing number work, for instance, I'm going to take my number work section out of there. And I'm going to see if it wants to play ball. And I'm going to X all of that and put it back here. so that I've got enough space to continue. And I'm going through number work first. So then I've got the ability to use conventional notarization, so brackets, powers, roots, reciprocals. Can they flip a fraction? Can they tell you that the idea of keep, flip, change? Do I keep it if it's a division question, flip the other one and change the other one? So keep the original fraction, for instance, like a quarter divided by half. Do they know that they need to keep and then change the sign in the middle, and then they need to flip the other one, so it's reciprocal? I would just, if occasionally, throw in the idea of, I've got a half, what's the reciprocal? And the response would have to be 2/1 or whole 2. I've got a fraction at 3/5. What is my reciprocal? 5/3. Just so you're building that idea of understanding and fluency. Using the idea of proper and improper fractions, they know that once they've created a reciprocal, it's 99.9% of the time it's going to be an improper fraction. Do they have the ability to then go ahead and look at improper fractions and decide that that's then what is a mixed number? When looking at that, I would then, if they're struggling at that point means you need to go back and look at division again, because we all know fractions is just division. We teach addition first and subtraction. They struggle with subtraction. We want to throw everything out. It's not that. It's just that one thing has been taught, and it's very hard to change what you've already been taught. Everything's taught in a positive fashion, and then we're expecting them to deal with negative numbers, which is kind of hard. Interpret fractions and percentages as operators. We've also got to do with recognizing things to powers of 2, 3, 4, 5, being able to add powers, take powers away, multiply. So all of the power laws, they need to know usually at this point. Working interchangeably with decimals, but also with fractions, they need to know place value of fractions, place value of decimals, the ability to change things into and out of what they are. Then you're going to be using the idea of maths, which we use a lot of maths for baking, cooking, things like that. Time, I use in reality. So I say to them, you've got 45 minutes to finish this. And I would then look at the idea of the concept of a sand timer again, because we have those. Then also look at how much can you get done in a period of time. So I know that they're not overestimating what they can do in 10 minutes and underestimating what they can complete within an hour. And then using that within the idea of decimal quantities. So if I said to you, I've got 2.25 hours, what do I actually mean? What do I actually mean in terms of 2.25 hours? And how that would work. If that 2.25 hours, I need you to get it into minutes, you know that 0.25 is going to be a quarter. What is a quarter of an hour? And then I need you to know that that's 15 minutes. You will get a few students or a few children who will mix up the idea of an hour being 100 minutes at this point. Don't be afraid. It happens to the best of them. Then for the last bits of number work, which you have, is using approximation through rounding, and your inequality notations, like A is less than X, but less than and equal to, I don't know, B. They need to be able to take those less thans and equals out, less than and equal to's out, and be able to add them into their notarization of not necessarily being fixed numbers, but also being able to set them within a graph. Calculator knowledge. I would take a whole period of time to fill in just calculator knowledge, because when you buy them a specific type of calculator, they need to know exactly where all of their buttons are, exactly how to use them in order to get their results. But then I also go back and say to them, if you have a answer on your calculator which looks way off, don't just rely on your calculator, rely on your brain also. Because if you've got that knowledge of what the previous bullet point said, which is notarization and the idea of finding that something is accurate, they need to be able to use approximation to then come back round and say to you, the answer on my calculator is X. This is what I've got, which is Y, and I need to know why they're so vastly different. Get them to work it out on paper without using their calculator so that they have an approximate answer of what they're actually looking for. So if it's like 2.002 multiplied by 4, and you're just having them use their calculator, 2.002 to the power of 2 multiplied by 4, they should know that that 002 on the end of 2 is going to be what they're looking at and what's necessarily going to be an issue. But using an approximation of rounding it down to 2 and deciding that, okay, I've rounded it down to 2. 2 to the power of 2 is then going to be 4. 4 multiplied by 4 is 16. If my calculator is giving me 38, what did I press that was incorrect? Do I need to try those buttons or those operations on my calculator in a different order? Then we need to appreciate the idea that numbers are infinite again, and we need to know the difference between real numbers, as in normal numbers, and rational numbers in terms of terminology. Usually they're dealing with a lot of numbers at that point. And when they're dealing with a lot of numbers at that point, you've got to remember that sometimes it can be overwhelming. When I talk about trips, I've got the idea of we are going to Math City. Trips sometimes can be in conjunction with exactly what you're studying. So Math City, we may go to more than once, for instance. We could also go to the park to do real life measurement. So we're looking at the reality of measure in the park. I would, then I would also look at if you've got a system on your door where you've always measured their height, you could ask them percentage-wise in the increments of how much they believe that they have grown. So what is the ratio of their growth, or how much have they grown in that period of time, and can they convert that into decimals? Can they convert that into percentages, and can they put it back into real measurements of meters, kilometers? If you are teaching your child a lot of things in abstract, the problem with abstract is that they don't have an idea of what it is in reality. So giving them a full-length ruler, which has 30 centimeters on, Flying Tiger Copenhagen now has a 50 centimeter foldable ruler. So if you're in a small confined space, and you don't have enough space to have everything that you particularly want, this is where you look at the idea of resources. When I look at resources, I tend to marry up my resources, especially online ones, with an actual idea of which particular website, which particular paper, which particular thing will I be using at the time. And I know that I have my go-tos now, so those are usually very easy for me to find. So I'm going to put a couple of mine in here. So as I mentioned a couple of videos ago, we have Maths for Everyone. Some people use Corbett Maths, because if you're struggling with maths and you don't have the fortunate ability to have someone that's going to be able to help you deal with their maths work, you've also got Corbett, which has the idea of solving everything that you particularly want to solve. Let's just find their main website, so we're not using a particular topic. Just corbettmaths.com. I will put all of these in the show notes to this video as soon as I get it up. So don't worry about that. You'll just have a clickable link that you'd be able to use. So we've got the notion of core bit maths. Some people go down the idea of using I class it as MME. It's MME Revise. Don't feel restricted to only using Key Stage 3 resources when teaching Key Stage 3. If you find that your student is very capable in a particular topic, go ahead and use whatever's available. So you may want to push them into GCSE, you may not want to push them into GCSE, you may want to look at other things. A lot of people recently have, because they have the systematic idea of looking for something that in a way makes it easier for you. Sorry about that. Quite a lot of people have decided to go down the route of using things like White Rose education.com. So they get workbooks and then an answer booklet. This is usually very good for people who have used things like Schofield and Sims and rely on an answer booklet if they need it. I believe it also comes with a teacher's guide, but then you also have Collins, who makes a very good Key Stage 3 textbook. So you've got the Collins textbook. And if you have a child that is very, very capable with maths, there is no harm, but no foul in your game of you going and saying, I'm just going to push them into Key Stage 4 because Key Stage 3 seems like a waste of time. We don't do Key Stage 3 in terms of subjects for very long, because I always find that Key Stage 3, I use it as a buffer zone. So if they did really, really well at Key Stage 2, or you have a child who did the 11 plus and passed really well with great scores, most of the time you don't necessarily need to go back over the concepts for Key Stage 3 for longer than about a term or two, because at that point they should know their stuff. So we've got previous knowledge, we've got trips and resources, and then I always leave a couple of blank things in between, because what I look at is things that need revision. And then I also note down adaptions required. I have a child, if I'm sending this off to the LEA, for instance, they're like, what's your plan for the next couple of years? No problem. My child, I know I have a child that requires a pink overlay on white paper, because it just helps her focus better. And that comes from knowing your child. It's not something I expect you to be able to just pull out of your hat. If you think your child is having an issue with their eyes, first optician's check. Second, if optician says everything's fine, or they say there's a slight stigmatism, try an overlay. So I always put where if I'm using something with my child, even if it's not for the LEA, it's just for my own personal knowledge. So I've got a few children. If I need to go back and look for the same thing for another child, I would then say, okay, where did we buy the overlay for Amara, for instance, who is my oldest girl at home? Where did I find one? And then you would decide, okay, fine, I might have bought that from the dyslexia shop. And if your child knows that you know that your child has dyslexia or dyspraxia or something of those ideas, there are lots of places for you to get that from. So I would pop in here, where did we buy it? We bought it, color ideas, we bought it at the dyslexia shop, for instance. So the dyslexia shop's a good place to go when it comes to things that you know that your child may need. It also works really well for children with autism. I have one for my son that has ASD. When he is using the computer, we have a computer overlay in yellow for him. So on his curriculum, it always says that he has his overlay on there. the revision, whatever I find that we may need to go back over from Key Stage 2, maybe it made sense in Key Stage 2, maybe we've just forgotten it. And we are not the sort of people, we don't take huge academic breaks. So we don't do academia from September to July and then have 6 weeks off, because having taught in the classroom, I know that summer gap or that summer lack of knowledge or that summer lack of studying means that when they go into Key Stage 3 or Key Stage 4, for instance, you've got to spend a lot of time going back over things that they already knew. I also have things such as meter rulers, centimeter rulers, millimeter rulers, all sorts of various tips and tricks to make life slightly easier for them. Even putting things in order, I tend to make flashcards with those sorts of things so that they have the ability to go ahead and look at those sorts of resources for me. When I look at resources, I then look at resources. These are usually online specific. And if I move trips over slightly, I'm doing this with you so I don't have to do it again later with her or for her. Resources, and then we have something that's very important in here is we have holiday dates also, because we usually take time off. We've got to take time off for Eid. We take the last couple of days of Ramadan off. We take off quite a bit of various things so that my children have some scope to breathe, but then also they have the ability to do what they necessarily want to do. I can't always have them studying 24 hours a day. I have one who would prefer to study 24 hours a day, but that's not going to be possible. You also have mum's work trips, so mum's days off. Because that would then decide how much of that we can actually get done and how much we need to get done and when we can push for certain things and not push for other things. So resources that we would tend to buy or make is the idea of flashcards. So every morning we would have some decimal ones and fraction ones that you can just print off or you can make yourself or you could purchase. I think I have a set that I made, which I have a PDF of, which were for sale. I don't know where they are now, somewhere on this computer anyway. So if we have flashcards for decimals, let's put an S on there, decimals and fractions, we can use those. I then also have algebra cards. And this is from having a child who was a very, very tactile learner who needed to have the ability to move things around. And as she moved things around, the paper meant that it was easier for her to go ahead and see where things went wrong. So even it took quite a long time to make these. I made a very large version of a systematic way of completing the square when she was doing quadratics, so that she had the ability to go ahead and do her notarization on something that was a dry erase board, so that it could be obviously wiped off. She could write her answers down in her book, wipe that off and work through the next question. Making those resources at the beginning meant that she had a very great concept of understanding. And then once we had the concept of understanding, we could go ahead and look at fluency. And then from fluency, we went for speed and accuracy of making all of those things correct. So we put all of those in. Holidays, we have Eid al-Adha. If you're not Muslim, then it's going to be like Christmas and all of those sorts of things, and maybe birthdays if you celebrate them. So we have Eid al-Adha and we have Eid al-Fitr. So usually we take 3 to 5 days for both of those. not necessarily mum having the time off, because that's a different story, but sometimes my children had the time off. But what we would do if we particularly wanted 5 days off, they would have the option of doing slightly more work on a weekend sporadically throughout. We run to a 4-day week. Our 4-day week means that they start really early in the morning, and when they finish, it's usually by probably about 9:30 in the morning, so that they've got time to fill in with whatever they're really, really interested in. So if mum has a work trip and we say she's going abroad and the children are not going, if I'm going to Ghana for 10 days, then they are off of work. They've got no work to necessarily do, and then they won't do any. If they're coming with me, they will pack 3 days worth of work for a 10-day trip. And either you've got some who will want to do their work really early on in the trip or on the plane, so that when they actually arrive at the destination, they only have 1 day's worth of work left or 2 days worth of work left. Then they will do one in the middle at, say, like day 5, by the side of a pool or something. They'll do work then, and then commit their time to do it on the plane home. But I set them deadlines. I don't say to my children, this is the amount of work you need to do every day individually. This is where I said to you earlier that I use time as a real concept. I give them a certain amount of work for the week. So if you are able to complete all of your work in 2 days, have at it. That will just make your life easier and my life easier too. I will tick things off or print these things off and highlight them as I go along to make sure that I know that they're meeting expectations, their own expectations and my own expectations, and I give them time and a date stamp on that. When we have finished, say, for instance, something such as number, we would then go ahead and move to a next topic. The topic that I usually end up leaving till last when it comes to maths tends to be algebra. And the reason why I leave algebra until last is because everything that is algebraic, we end up doing, it ends up covering every other individual topic. So if we cover algebra first, and they haven't necessarily decided or been able to understand the other topics at their disposal, we have an issue. So if you want to draw your table in a different way, I'm going to give you a different way to draw your table. We have the idea of probability and statistics that also needs to go in. I tend to teach probability next after number work because it just deals with the scale. They need to be able to record probability, describe probability, understand how probability works in that sort of idea, use it, and we will then decide things like, are we using a game of cards? So if I say to you, there's 52 cards in a pack, what is the chances that I'm going to pick out a number 4, for instance? I'm not going to make them do that in an abstract fashion. I'm going to make them do that in reality so that they have something tangible to hold on to mentally as they work through questions that might be slightly harder. So if Timmy has a bag of buttons, for instance, and they're all green buttons and there's one blue button, what's the probability that he's going to pick out a blue button? I will find a bag and we will put them all in, and I'll make sure it's an opaque bag, so you can get colored organza bags or a mesh bag, or what are they? Canvas bags, tiny canvas bags from Hobbycraft, for instance, and be able to put all of the buttons in or all of the balls in. If you have one of those chemistry building kits, you can use the atomic structures from there just to fill the gap. So you're not buying two sets of resources in something that may go awry. Because we all know, especially if you have younger ones, stuff goes missing. And it's frustrating, but we love them anyway. Wouldn't trade them for the world sometimes. And then they need to be able to see, is someone got on blue socks? And then we've got enough people in the house, or when we go to homeschool group or whatever, to say, okay, you've got a room of 20 people, and how many of them, what's the probability that all of them have on blue socks? Highly unlikely, because they don't wear school uniform. But if they were to put that into the idea of using a Venn diagram, you could be a girl with blue socks, but you could also be a girl with white socks. But both of those things that are in common is they're both girls. And having that crossover. That works really well when teaching things like sociological concepts also. So not all of us are the same. We have uniqueness about us, have the ability to go through that. After probability, I tend to move on to statistics because stats are very useful. They could choose to sit a statistics paper also. And from a statistics paper, you are looking about graphs representation. And when you're looking at graph representation, that's very, very important to have the ability to describe a graph. Because some of the questions that they will get later on is, how do you describe what is going on this particular graph? And if you're describing what is going on in a particular graph during statistics, it's going to be very easy for you to do it later on, when it comes through that idea. Number work, where you talk about averages and statistics. Here we're also looking at things like mean, median, mode, range, spread, consideration of outliers. If we took the outliers out of the group, what does that represent? We then go ahead and look at how that sort of stuff is used in real life, for instance. How do we look at the data on the bottom of, say, for instance, a new advert? If it says to you, we had 6, 7, 8, 9 or 950 people that were involved in this study, and 67% of them said that they really liked the product, what is the chance that the rest of them did not like the product? Then it's the idea of, would they have taken out the outliers? Why is taking out the outliers very important? Why would you decide to take out the outliers, especially in something like a test? But then also using their scientific knowledge. If I was to take the outliers out of, I don't know, a chemical trial, what would be the reason that I would take those chemical outliers out? What would that actually do to my data? And how much more valid would my data need to be? And we look at things in that regards, things like NICE guidelines and how that would work in the real world. So we take maths into the real world, because what you tend to get is when you have students who don't particularly like maths, you've got to be able to say to them, oh, all right, you don't like maths, no problem. We're going to learn it anyway. But giving them the ability to see how the amount of mathematics works for them in their everyday lives means that when they've got something that they can hold on to and think, okay, that's the reality. Okay, that reality means that this topic now holds more weight mentally. And if it holds more weight mentally, I'm then able to go ahead and look at how that would work for me. And so with this, we've got mean, median, mode, and range. So I will put down, say, for instance, statistical data. So we could go back and look at things like elections and financial distribution. how is it that we have this notion of the idea of something called a postcode lottery, especially when it comes to health, when it comes to wealth? Why is it that we statistically have areas in social deprivation, outside of social deprivation? Why would all of that be a thing? Then if we look at how that would be represented in a pie chart, we would go back, and I like for my children to be able to look at real data. So you could look at things like the Unilever website. Let me actually get the website and then I'll pop it in here. So you can look at the Unilever website, things that are open to the eye. Why would you represent something like how quickly you can look at something? Why would you represent it as a pie chart rather than a bar graph? And it would be the idea of why would you make your pie chart stand out so much? And that's because you need it to be eye-grabbing for the initial read so that people are more willing to invest in your ideas. Looking at it like that, they tend to get a bit more out of it. And when they get a bit more out of it, they tend to do better with that particular topic. If we are then looking at categorical ideas, we could look at things like the government website. The government website doesn't really use as much statistical data in terms of pie charts and bar graphs and things like that. And having spoke to quite a few different governmental departments, it's actually because the website doesn't actually gel really well with using statistical data in order to create things like pie charts and bar graphs and things like that. You could have them in this idea create their own Facebook groups for home editors, your WhatsApp groups, put a poll in and ask people a specific question from your child. If you need a large sample of data, ask them a specific question from your child and have the group come back to you. And when the group comes back to you, even if you have a spread of like 15 or 20 people, they have to be able to convert that into a bar chart, from a bar chart to a line graph. From a line graph, they need to convert that into a Venn diagram. They need to be able to convert that into lots of, using one set of data. How do you convert that into several other things that maybe need to happen? So if they create their own charts and graphs using collected data. If you've got a teenager who particularly likes to spend a lot of time on their phone, you could also use their phone usage data to point out to them how much of their time they are not utilizing very well. And this is where, at this point, usually your child's probably about 12, 13, if you're doing it according to the normal guidelines of when someone does something. School age wise, mine are usually about 11. This is where I teach them the idea of a time audit so that they know how they're using their time, how they're using their time well. And if they spent more time, I don't know, at the mosque, or they spent more time reading Quran than they did dealing with their phone, for instance, there's benefit and reward to that, which is passed down by mum. So, and then we also need for them to look at two different sets of data and the ability for them to look at. I found with my one, the idea of the election was very useful, and it was the compare and contrast, the loss and gain of seats in certain constituencies. Was it a gain for Labour? Was it a loss for Labour? Was it a gain for independents? Was it a loss for the Conservatives? Was it a gain for Greens or was it a loss for Greens? And then what is it and what could be the reasoning behind that? So a lot of maths could be taken into a conversational aspect, especially if you have a highly political child. I have highly political children because I'm a political nerd, so they are sort of stuck with that. So we also have geometry and measures. And if we are looking at this, this is slightly more of the one that requires your energy, apart from number work. This requires your energy because there is a lot of this when it comes to algebra. This is one of those things that if they don't have a solid grasp of 2D and 3D shapes really early on, it hits them very hard when it comes to algebra, because it may have an idea of this is an algebraic topic that we need you to cover. This is the question, and they really don't know what's going on. A good idea is to grab, we have a nice big circle which you can draw on, and then tracing paper. And I give you a line and I say to you, where does this line go? And if it goes here, if it's a radii line, for instance, where does it go? And then I don't give them a line that has diameter on, for instance. I'm like, but I need to work out the diameter of this line. What would be the diameter of this line? And they would say to you, well, you've got the radii, so multiply it by 2. You've got the diameter, and I need the radii, divide it by 2. I always have my children go through their questions with a highlighter so that they can highlight what is exactly important about the question, so they can work out really quickly what is the question actually asking you to do. The use of a compass is very, very important for when we're doing things like perpendicular bisectors. So drawing on those lines, those notation lines, finding out how we're going to draw on those notation lines and those construction lines, because some of the questions that they may come up against will say, leave your construction lines. And if their construction lines are correct, but they're slightly off, they are awarded marks. If they are not using construction lines and then their stuff is slightly off, they won't get any marks whatsoever. Triangles, quadrilaterals, circles, other figures with a similar plane, equal lengths and angles, appropriate language and terminal and technologies. Do they know how to work out things on their calculator? Do they know what the underpinning is for sin, cos, and tan? The buttons on their calculator, do they know what the graphs actually look like? So I always say to my students, remember your exact figures. And at this point, I go ahead and I teach exact figures. If it's anything that they can memorize really quickly, teach it while they're younger rather than older, because we all know the brain starts to solidify a lot more in that idea. Properties of angles at a point. So angles on a straight line, 180, angles around a point, 360, angles inside of a triangle must equal 180. Why do they equal 180? Prove it. Okay, so then we've got 2, we've got the number of sides minus 1 multiplied by 180 gives us our answer for internal angles. Teaching internal angles and external angles, all of that sort of jazz is absolutely necessary. So we've got the idea of the sum of what I was talking about just now, the sum of the polygon. We really need that stuff embedded. Can you talk about similarities, probability of things being the same shape if they are of very similar shapes? And also teach them that the diagram that is on the paper, if it says not to scale, is not necessarily going to be that useful if it's not to scale. It's supposed to give you some sort of visual representation, but sometimes the question doesn't necessarily match the actual answer that you are required to give. Pythagoras' theorem is very important here. Knowing how to obtain simple proof of Pythagoras' theorem. Are they able to work backwards through the answer of Pythagoras' theorem to give you the answer? And this is where we have the idea of using trigonometry with ratio. That's why I said teach number work first and come back to things like geometry later, because all of the number work needs to be solid in order for the geometry to necessarily work. Using Pythagoras' theorem and SOHCAHTOA for trig at this point is very, very important. There's no point rushing ahead with saying, okay, that's fine. I'm going to teach them other triangles if they still don't know this, because when they get to the Key Stage 4 level where you need to teach sine and cosine, you could go back and teach all of this at once. So sine, the sine rule, the cosine rule, and trigonometry all at once, but then you end up with geometry overload, and then they end up hating geometry. We've talked about probability and statistics, and then we need to go and look at ratio, proportion, and changes of range. There is a lot of this which is very similar to the Key Stage 4 curriculum. So if this stuff is embedded really quickly and really rapidly, or it's embedded to the point where the child has the ability to just make connections, you've got 2 years now. Key Stage 3 has been condensed into 2 years, but it's actually 2.5 years because it's just so they could start GCSE curriculum a lot earlier on. But I find that a lot of this stuff like Pythagoras' theorem are pretty easy concepts to understand at Key Stage 2. As long as you're willing to do things like big paperwork, sit on the floor, draw things out. We had a lesson a few months ago where I taught my children vectors using toy cars. Vectors is not something they're supposed to cover until Key Stage 4, but my children are great guinea pigs for when I have a new teaching standard that I want to implement. And my 7-year-old, who has some additional needs, not necessarily academic additional needs, because him and his work are alhamdulillah, quite good together. It's more of a sense of he needs some extra additional help in terms of focus, things like that. He was able to grasp the vectors, and then giving him an exam question from a paper of 2023, he was able to grasp it really easily. So it's your approach that requires the work. If you've got something that you don't particularly understand, and you want to find a new way of teaching it, put it in the comments of this particular video, and I will get back to you and sort of say, try and lead you in the right direction of how would I teach it? And is there another way to teach it? And I'll come back to you with resources and various other things, just because I don't know. I like teaching. It's one of those things. We need to be able to deal with ratio and proportion and rates of change. So we need to be able to convert time, minutes, seconds, hours, quite easily. Usually with my children's work, once I go into the idea of planning when their terms are, when we're taking time off, I will then, look at converting time with them. So questions such as, if a jackhammer moves in seconds and I need to have this work done in 3 days, is that possible? Show me your working. They'd be quite proficient at doing something like that by this point. Using scale. Once you introduce your children to an atlas in terms of time, in terms of space, they should be able to move scale on a map. You don't need to wait until Key Stage 3 to do that. If your child is younger than Key Stage 3, I suggest you do that quite quickly. Just say to them, okay, how do we fit the whole map into this particular book? Because we can't fit the entire world into our home. So how are we fitting that in? And they'll say, oh, well, we've shrunk it down. Okay, to shrink it down, how much do we have to shrink it down? then you get to look at the scale on the bottom of your map and say, for every half a centimetre in this book, and you show them half a centimetre on a ruler, we have got 5 kilometres. And then you would say to them, realistically, let's jump in the car, we're going to drive 5 kilometres, to see how much of a representation 5 kilometres is, for you to think about walking that distance or driving that distance if you don't have a car, or driving that distance. If you're driving that particular distance, how long did it take us to get there by driving? How long would it take us to get there by foot? So you could have them do some investigations about looking at the average human speed and how quickly someone will walk. If someone's going to walk at a very quick speed compared to the average person, okay, great, no problem. But how far does the average person walk, and see how quickly we can change that. We look at the notation of ratio, so the idea of the colon that we use, and then reduction into its simplest form. If you've got something that's like 21 to the ratio of 70, could we make that much smaller? I tend to teach ratio notation along with simplifying fractions, because it's just an easy concept for you to match things up. So if I can put 7 into both of those, how small does it come down? Okay, it comes down 3 to 10. Is there another number that goes into 3 but also goes into 10? No. But while doing that, you're also checking their number knowledge and their division skills for proficiency. I tend to group, and we'll look at this in a minute on a whiteboard. I tend to group all of the division topics together and all of the addition topics together and work with them the way they are, and then tick them off as we go. So if I am working with fractions, for instance, and decimals, and also then ratios and percentages, I would work all of those around the idea of doing minus. So minus is the cousin of division, and from division we get all of these. From getting all of those, do we know how this is going to work for each individual topic, and then put them into question form? This stuff does not need to be reduced or dumbed down, in a sense, if your child has issues with their reading but is very good at maths. What you can do is push the maths, but then pull the reading as much as you possibly can without breaking the child. You've also got to think about the language of ratios, but then this is where you also talk about the idea of direct proportion. So if I add to something, it's going to gain more weight. If I subtract from something, it's going to lose weight. But what happens if I increase the speed in which I do something? It means that the work takes less time. You can have those sorts of conversations as conceptual conversations. If you spent less time watching television, which means less time, you would have more time to complete your work, which meant that you would have more free time. Is something we say to our children very often, but then we could say to them, that's how I've been teaching you time management, not only time management, but also the difference between inverse and direct proportion. Then we're looking at the idea of algebraic representation. This is where now we need to look at when we're mixing all of our things together, and that's under the brand of algebra, the joy. We need to explain that an A standing next to a B literally means A multiplied by B. We need to explain that 3y is essentially y plus y plus y. We need to also explain that something to the power of 3 is in the place of you saying A multiplied by A multiplied by A. So just teach them that this is, I teach it as cheat code. I say to them, this is cheat code, and the cheat code is necessary, and it just makes your life easier, and it makes it easier to read. So I say to my children, I've got 7 y's. I've got y plus y plus y plus y plus y. I don't want to write it out like that. What's my cheat code? And they'll say 7y. Even little ones can get that. but don't introduce it until you know that they're comfortable with their numbers. We've been doing algebra from the beginning. It's the idea of if you've got 7 plus 3, what is your answer? That answer could have always been the unknown, which is X or Y or A or B. Substitution is the next thing that needs to be taught, being able to put numbers into an actual framework of this is a number and I want to put the number into this particular formula to work out what the answer would actually be. Okay, fine. Here's your answer, but where's the question? We've got the question. Great. I want to put it in. Let's put it in to see how it works. We've been doing this for years with the idea of number machines. We're putting it in, it's going to be multiplied by 3, added to 4, then where are we coming out of it? So go back and fish out those number trains that you've had, and then we could do that exactly with an X or with a Y. You just need to add that little bit extra. This is why making your own resources or buying resources that are specific or which you believe are specific, but then finding multiple uses for them. Taking out things that are common, I usually have even my students, I'll have them open them up. So if it has an X and then it has 2Y, but then it has 3 Zs, and then the other side has a couple of Ys and a couple of Zs, how many of those are common? How many of those could we pull out? And then cheat code again. How do we use that to make our lives easier? So I like to explain to my children, mathematicians are lazy. And I need to teach you the cheat code that mathematicians use so that you can be accurate, but also be lazy. And then I have to explain the difference between lazy and sloppy. So lazy and the idea of making things work for you, but then being sloppy is not what we particularly want them to do. Expanding brackets, making things common, binomials, all of that sort of random jazz needs to come into here. Using the idea of X and Y, this is where we know that they've already been introduced to graphs by now, but now we are using algebraic ideas of graphs so that we have the ability to go ahead and just make a terminology for how each individual of the 4 quadrants is placed. Usually they had been using 2 quadrants until this point, or 1. Usually 1, just that top right-hand side is what they've been using. Now we are introducing that there are 4 other sides, 3 of them which go into negative and positive, one that goes into negative, and positive, the other one that is also positive and negative on the other side, but then we also have one that is completely negative at the bottom. That's why their number knowledge of negative numbers and the way that negative numbers work needs to be solidified before they can go on and do the further bits with algebra, especially the things that require tables or graphs, because they would need to be able to work that through and then be able to plot it onto the graph. Plotting it onto the graph is also very, very important. This bit where it says generate terms of sequence from either a term to term or position to position rule. This is actually more commonly known as nth term. What is the term? What is the formula that can be used to understand all of these things? Then we've also got the idea of recognizing that this is an arithmetic sequence and then going ahead and finding the nth term. So it's understanding that terms actually happen in sequence and then going ahead and being able to find your own mathematical sequence. We have the difference between an arithmetic sequence, which is a very simple nth term, which is n minus 1, that sort of idea. But this is where we start to get into geometric sequences. So triangle numbers, squared numbers, but then also going into things like Fibonacci sequencing, the different types of Fibonacci sequencing, looking at those and deciding that how do they work, but then also looking at that you may end up with a quadratic as your answer. And this is your first, at Key Stage 3, your first introduction to the idea of a quadratic. And that is where your time with quadratics starts. This is the entirety of the Key Stage 3 curriculum in terms of maths. How you want to teach it is totally up to you. But then you could also go over to the Key Stage 4 curriculum of study, realize that they all have the same titles, all have the same aims, and also have the ability to say pretty much the same things, just taking it slightly harder. So in your number work, you'll be including things like surds, standard form, identifying and working through ratios with fractions, upper and lower bound, and truncating. So rounding, truncating, 3 significant figures, 4 significant figures, being able to apply that. Then you would include the idea of factorizing, quadratic formula, completing the square, arguments and proof, and being able to rationalize your response. But if you've taught them to rationalize their response very early on, it won't necessarily be a problem at Key Stage 4. That would be very easy to do. They'd be able to solve linear inequalities, but also quadratic inequalities. Ratio doesn't change much. It's more of a sense of consolidating everything from Key Stage 3. Geometry, the same. Consolidating Key Stage 3. But then you'd have some additional stuff. So enlargements, for instance, interceptions and bearings. Arc lengths, but you should have been able to cover arc lengths during Key Stage 3 if the child was capable. Surface area. So rather than it just being the internal volume, you need to be able to do surface area. But then have your child look at 2 types of question, where one question talks about volume and the other type talks about quadratic formula. Surface area, and see how they would be with the difference of that. You would need to, at this point, what I was talking about was the sine and cosine rule, taking Pythagoras' theorem to the next level by doing things like 3D Pythagoras. But if you have a solid relationship here, you should be fine moving into Key Stage 4. So if you were to look at this, you would go across and create what I would create, which is I'm going to merge these, and I keep clicking the wrong thing. So if I merge these cells and I put topics from Key Stage 4 already covered. So if one day you're having a conversation about the numbers on the buttons on their calculator, which are sin, cos, and tan, and you say to them, sin, cos, and tan have exact values inside, and you go ahead and you teach your child exact values, then there's no shame in your game there of teaching them exact values. Yeah? So if you go ahead and teach them exact values, no problem. Allow exact values to be taught. So they've been taught exact values for sin, cos, and tan. And then you go back to say, if they liked Pythagoras, for instance, and you took it a bit further, you could say, I went down the route of 3D Pythagoras. And I'm not saying to you, have your child sit down for 4 to 5, 6 hours a day, deciding that this is what you're going to have them do, and you want them to do it now, and making your child's life miserable. What I'm saying to you is, if they have the ability to go forward, go forward. If they don't have the ability to go forward, do not keep pushing, because eventually you just make them hate the subject. if when you were doing mean, median, mode, and range, you decided to add in box plots, for instance, so that they now know how to draw a box plot. So you had already taught interquartile range, for instance, and you'd also taught upper quartile alongside upper quartile and lower quartile. You don't need to then teach that again. I'm not saying to you limit yourself to the stuff that's also in the Key Stage 3 curriculum if your child has the ability to go further. If you end up with a child like mine that I say to you, okay, there's 3 ways of solving a quadratic, because we've got to the point of a quadratic. Oh, and she will, to her next question will probably be, it's 3 ways. Okay, I'd like to know what they are. So you sort of, okay, we've taught you quadratic formula and you enjoyed that and it was quite fun and you've remembered the formula. You could also put in here that it's already been memorized. So when you come to plan for the following academic year, if you've managed to cover all of the Key Stage 3 in a year or 2 years, even if you started at, say, age 10, age 11 with Key Stage 3, early age of 10, 11, so where they would have been year 5, year 6, if they've already memorized quadratic formula, that's fine. And that's actually quite good. And then if they are very proficient with things like their times tables, I don't see why you can't go on. Once you've started algebra to teach them things like factorization. Once you've taught them factorization, the idea of completing the square. If you've already taught them all of that, all you're doing is revision in Key Stage 4. You're not necessarily going back to do anything extra. If we have consolidated proportionality and we now understand that X can be inversely proportional to Y, so it makes it X is proportional to 1 over Y, that sort of information, if they know that stuff already, you don't need to go back and teach it again. As long as you know that they know it, you can just do a revision idea and that's it. Once you've got the, and then you also need to talk about rates of pay. Is it in the best interest? If your child's already someone who runs a business, is it in your best interest to have a rate of pay for a person which is a daily rate, or is it better for you to have someone who works by the hour? And the person will say it depends on the person. Okay, fine. So I have someone who could do the work that you want them to do in 3 hours, and I have someone who you want them to do the work and they do the work in 8 hours. Is it cheaper for you to pay them a daily rate, or is it cheaper for you as a boss to pay them by the hour? And they'll say, okay, for the person who works within 8 hours, a daily rate is best. And if I have a person who works for 3 hours, can I compare and contrast and make sure that they're also got a rate that is proportional to the amount of work that they are indeed doing? I'm going to save this because I need this personally. But all of the links to the curriculums that we've used to open these things up and all of the links that I've put inside of the curriculum bit it's already been saved, are automatically on your, would be in the show notes for this particular video. But then let's work on a whiteboard. And I will show you what I mean by grouping things together in terms of making that idea work for you. So you're not going all over the place in the way that the curriculum, when being explored in schools, actually does. At times, you've got to think that school operates for a certain amount of time. So they don't have a flexibility on, if we finish the curriculum, say, for instance, in March, we can finish in March. The teachers don't have that sort of freedom. So if they don't have that level of freedom, they're not going to want to, there's no incentive to finish it earlier. because you're just going to get in trouble for rushing it through, even if your children are very capable of doing what you are asking them to do. So let's grab a whiteboard and then we can finish off there. So we're just loading up a whiteboard here. So then we have, say for instance, we have maths topics, linked to division. If you find that your child is struggling with division, it gives you an idea that they may struggle with a few other things. So we are talking fractions here. Long division and short division. I've never understood the need for long division. It's just long for no reason. We have other topics that are linked. So the idea of a ratio, proportion. So if you want to do a division-focused year, that's something that's perfectly plausible for someone to want to do a division-focused year, because that means you can copy or go through all of the topics that are linked to division. Let me just grab another set of notes here. From your fractions, you're going to end up with the idea of decimals. You've got proportion here. We are then linking percentage increase and decrease. So percentages. We are talking about, when we're talking about division, do not forget division by 0, because that comes up a lot algebraically underneath. Then we're talking about, if your child is okay with division, we could add in the algebra idea of division. We also have to talk about things like prime factorization. Intervals. And if your child is studying computer science, you could link this with their computer science, because we're talking about remainders. And turning your remainders, or converting your remainders into converting remainders into fractions. So linking that back to this. So if we're converting remainders, we know exactly what we're doing and how we're doing it. We've also then got the idea of things like polynomials, but we can take that for when they get a little bit further into math, and then you're looking at the HCF. So the idea of the highest common factor. All of those are linked to division. And if they are linked to division, we don't necessarily need to look at division as being something completely different. We can look at division as being something that we have the ability to work with. And if we can work with division quite easily, it won't necessarily be a problem for us later on. I hope all of this helps. If you've got any questions about anything I said, I know it's a long video, so take your time, set it up however you feel like setting it up. come back to it, take your notes, take screenshots. I'm perfectly fine with any of that happening. Share the video with a friend if they need to. We are going to be putting out quite a lot of this type of content to help home educators, but then also parents who their children may be flexi-schooled, or we have the school refusal community where you need to plug those gaps. What your child is missing when they're refusing to attend mainstream school. The next video for this one will be a science, planning your yearly science curriculum, or for the whole of Key Stage 3 science curriculum, followed by English, and books you may want to read or touch upon really quickly, or books you may want to go into a lot more depth in. If your child's involved in politics, maybe something like Animal Farm, for instance. Or going from Key Stage 3, we will be moving up to Key Stage 4, and then there will be a video on finding an examination centre and the best examination centres for you. So I hope this really helps. Assalamu alaikum.